Somewhere in a colony you've never heard of, an ant is about to lock its jaws onto a leaf and never let go again. Somewhere else, an ant is about to blow itself apart on purpose. And somewhere else, a group of ants is running across the surface of the ocean without drowning. None of these are science fiction. They are real ants, alive right now, doing things that sound like they were invented for a horror movie. In the next few minutes, you'll meet 8 of them, and every single one breaks a rule you assumed all insects had to follow. Stay to the end, because the last one doesn't just break the rule. It turns dying into a weapon. The ant that gets hijacked by a fungus. Deep in a tropical rainforest, a single fungal spore drifts down and lands on a carpenter ant going about its normal day. That one moment is the beginning of the end, but not right away. The fungus, Ophiocordyceps unilateralis, doesn't kill its host. It moves in. Over the following days, it spreads through the ant's body and starts overriding its brain's instructions. The ant stops following the scent trail. It stops taking cues from the rest of the colony. It leaves the group entirely and starts climbing, alone, upward, with no memory of why. It doesn't stop at just any height. It stops at the exact temperature and humidity the fungus needs to grow, as if it were following a checklist it never wrote. Then it clamps its jaws around a leaf vein in what's known as a death grip, and it never releases again. Days later, a fungal stalk erupts from the back of the ant's head and showers spores onto the trail below, right where the next ant will walk past. The ant was never in control. It was infrastructure, the ant with a built-in ejector seat. If the last ant lost control of its own body, this one has the opposite problem. It has too much power stored in one place. The trapped jaw ant holds its mandibles open like a cocked spring, locked until the moment it decides to fire. When it releases, the strike happens faster than the human eye can track. Fast enough to stun prey instantly or crack open an exoskeleton much larger than the ant's own body. But here's the twist almost nobody expects. Those same jaws double as an escape hatch. Snap them against the ground hard enough, and the recoil launches the ant's entire body into the air, backward, sideways, however the physics land. And it disappears into the leaf litter before a predator can react. One weapon, 2 completely different jobs, kill or launch and vanish. The ants that turn their own bodies into food jars. In dry regions where food can vanish for months at a time, some ant colonies solve the problem in the strangest way possible. They don't store food in the ground. They store it inside each other. Certain worker ants, called repletes, are fed liquid sugar until their abdomens balloon into glassy, amber-colored spheres. They swell so much they can barely move. So they simply stop moving, hanging from the ceiling of the nest for the rest of their lives as living storage tanks. When another ant is hungry, it walks up, taps a replete, and receives a shared drop of liquid on demand. Indigenous communities in Australia have known about this for generations, sometimes digging up the sweet-filled repletes as a rare treat during the dry season. This colony didn't build a pantry. It grew one out of its own members, the ants that build with their own babies. Every nest needs a way to hold itself together, and weaver ants found a building material no other animal uses: their own larvae. Adult weaver ants can't produce glue themselves, but their larvae can. So workers gently pick up developing larvae in their jaws and press them along the seams where 2 leaves meet. Squeeze just enough. The larvae release a sticky silk that binds the leaves in place, like a construction crew wielding a glue gun that happens to be alive. The larvae don't choose to do this. They're a tool being operated by the colony. Once the seam holds, they're returned to the nest to keep developing. Multiply this across an entire colony, and you get nests the size of footballs, built high in the trees across Africa, Asia, and Australia. Most builders use mud or wax. This colony's nursery doubles as its toolbox, the ant whose head is the front door. Somewhere inside a hollow twig, a single ant is doing a job that will last its entire life: being a door. Certain turtle ant workers are born with flattened, disc-shaped heads, not built for fighting or feeding, only for plugging the entrance to the nest. They wedge themselves into the opening and stay there, checking every ant that approaches by scent, match the colony's signature, and the guard tilts its head aside to let them through. Fail to check, and the head doesn't move, no matter what. It's a living lock, grown into a body that was designed for exactly one purpose. Because the door rarely fails, the colony rarely has to fight. And in some turtle ant species, the same body plan does double duty. When they fall from a branch, they can glide back the trunk in a controlled descent, a security guard that also happens to know how to fly. The ants that survive getting swallowed by the ocean twice a day. In the mangrove forest of northern Australia lives an ant that should not exist by normal ant logic, one whose entire home gets submerged by the tide twice every single day. When the water rises, the nest of Polyrhacus floods completely. Any ordinary colony would drown within minutes. Instead, these ants seal off sections of their tunnels ahead of time, trapping small air pockets that keep workers, eggs, and larvae alive until the tide pulls back. The moment the mud is exposed again, it's a race. Workers rush out to gather food before predators like fish, crabs, and mud skippers close in at the waterline. Some can even skate across the surface tension of wet mud, and others swim short distances to get where they need to go. Every high tide erases the ground beneath them. Every low tide is a sprint to survive before it comes back. The ants that feed on their own children without killing them. Insects don't have blood, but they do have a fluid called hemolymph. And in Dracula ants, the adults have found a way to live off it, drawn straight from their own larvae. Workers open small punctures in the larvae and drink the fluid inside without killing them. The larvae keep growing. The adults keep returning. It functions like a nursery that recharges itself, a food source the colony never has to hunt for, because it raised it. Dracula ant colonies tend to be small and hidden away in soil and rotting wood, without enough foragers to feed everyone the normal way. So evolution found a shortcut most other ants never needed. And in some species, there's a second shock. Their jaws snap shut faster than almost anything else ever measured in the animal kingdom. Even faster than the trap-jaw ant from earlier in this list, the ant that detonates itself to save everyone else. This is the one from the very beginning, the last rule breaker and the most extreme. In the rainforest of Southeast Asia, Colobopsis explodens carries a pair of glands running down its body, filled with a sticky, toxic yellow substance. When a threat gets too close and there's no way to fight it off normally, a worker does the unthinkable. It ruptures its own body on purpose. The glands burst. The toxic fluid sprays across the attacker, coating it, slowing it down, sometimes trapping it entirely, buying the rest of the colony the seconds it needs to escape or respond. The worker that did it does not survive. It was never going to. This is an accident or a malfunction. It's a purpose-built last resort, evolved specifically to turn one individual into a weapon the moment the colony needs it most. Most animals are wired to save themselves first. This one is wired to make its own death useful. 8 ants. 8 rules that shouldn't be possible. A body hijacked by a fungus, a jaw that doubles as a rocket, a colony that turns itself into a pantry, a nursery that builds a nest, a skull that works as a lock, a home that vanishes twice a day, a food source that regrows itself, and a death built to protect everyone left behind. None of these ants are the exception to how colonies work. They are how colonies work. Every one of them proof that the individual doesn't matter nearly as much as the group. Which one of these felt the most unbelievable to you? Put it in the comments. And if you want the next one to be even stranger, you already know what to do.